And so today what I want to do is finish off our discussion about modern atomic theory. So we began yesterday by talking about Bohr's model of the atom, that solar system model where electrons are confined to discrete energy levels, and that an electron would need to gain a very specific amount of energy to move to transition from its ground state to an alternate higher energy level. And so Bohr's model over time we saw was useful in many respects, and I'll discuss that in class. But however, over time we also saw some significant flaws in that model. And so that's what I want to kind of start with today. So let me introduce you to two significant figures in the world of chemistry, physics, Schrodinger and Heisenberg, and you may have heard of both of those names. Schrodinger has a famous experiment referred to as the Schrodinger's cat experiment, and then we'll talk about that in more depth in grade 12 chemistry. And Heisenberg, you may have heard through maybe the popular show Breaking Bad, may not know much about him. So these two were sort of pioneers in quantum mechanics in that they saw some significant flaws in Bohr's ideas and developed what we refer to as the quantum mechanics theory, and their ideas surrounded that we can't really know exactly where electrons are, and they certainly can't be confined to orbits as described by Bohr. So I've got an animation here that's meant to help you understand their ideas, even though we won't be going into any depth at this level around what their concept of the atom was, and we're just going to kind of deal with it at the surface level. So I want you to imagine, you can see this red dot that's moving around sporadically. I want you to imagine that it's sort of been stamped in ink, and that everywhere that it goes, it's kind of creating a bit of an imprint. And so you can see that there are certain regions that are getting more sort of imprints than the others. And, certainly around the nucleus, we're seeing a less dense area of ink imprints. And then as you move away from the nucleus, also there's a region with less density. And so what they postulated was that the electron is sort of traveling around in three-dimensional space around the nucleus. We can't predict at any one moment in time where it is in absolutely, but we can certainly make some sort of statistical analysis and determine some probability of where it's located. And so where we see the more sort of densely packed ink blots, that's describing the more likely probable spot where that electron is going to be. And so they called these electron clouds. So as opposed to orbits with discrete energy, we're looking more specifically at these sort of parameters, which they've called electron clouds, that describe the likely location of electrons. So electron can be anywhere within that sort of probability density. Let me show you a few more diagrams around that. Okay, so Schrodinger and Heisenberg, sort of their ideas together, it kind of gave us this idea that the electrons were in these electron clouds. So here you can see these electrons traveling in these areas of, and it kind of together, those ink dots sort of form like a bit of a cloud. And so what we also know is that those clouds don't need to always be spherical. They can have different shapes and kind of sizes, if you will. And so here is what we would call an s orbital. We're not going to go into too much depth this year. Next year, that will be a bigger topic. But you can see that, an s orbital does have sort of that spherical shape. A p orbital has what we sometimes call as a dumbbell shape. You can see the greater probability density in these two kind of lobe areas. Here what we have is one of the d orbitals, but again, you're not responsible for really knowing what these are this year, except to just understand that they are a thing, and that electrons, we can sort of use Bohr's ideas to help us understand the atom, but it is kind of limited in terms of how it describes the structure of the atom. So that's it for these ideas this year, and this is where we're going to take off and remind you of some trends that we can use based on Bohr's model of the atom, understanding that it's not really a true depiction of what we understand the atom to look like any longer, but there's still some useful nuggets we can grab out of that. So as always, if you have any questions for me, make sure that you touch base and reach out and ask for some clarification. Happy to help.